Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding Geometry Dash in Java series. In the last episode, what we got to was we began to enable editor controls to move selected objects, duplicate selected objects, and more with that. Today, what we're going to be doing is rotating selected objects. So rotating them and then enabling box select so that we can select multiple objects at the same time. This should be pretty fun. This should be like the last little bit that we have left to do. After this, what we're going to be doing is some stuff with portals and a little bit more with box bounds, getting some like trigger box bounds that only trigger a function, and then getting some killing box bounds that will kill you no matter where you touch them. So that should be it for the Geometry Dash series as well. Let's get started and enable rotation for our editor controls and enable box select for our controls. So let's go do that real quick. Like I said, in the last tutorial, what we got to was the ability to place the blocks, and then we can multi-select now, and we can move them short increments or large increments. And if we move them short increments, it snaps them into place when it should. So that's basically all we did in the last tutorial. What we're going to do in this tutorial is actually enable the rotation so that we can rotate these objects, which I'm betting you're guessing is pretty easy. So we literally just do the same thing we've been doing. We just add another key binding to our level editor controls class. So let's go to our level editor controls class. So here's our update loop, and as you can see, it's getting pretty big too. We could add in another, like a few more functions to abstract some of this stuff away and make it a little bit smaller, but I'm going to leave it as is. If you guys want to refactor the code and make it better and continue building upon this game after this tutorial is done, I would definitely recommend refactoring this a little bit and abstracting some of these into functions, some of these big if statements and stuff. But let's do our binding for the keys that we want to rotate. So say if the debounce key is less than 0 and the window.keyListener.isKeyPressed, and we will do, I'm going to do Q and E for rotating just because we already have D bound to something. So that should be good for us. Oh, and then we need to do VKQ. There we go. And then we'll do one thing else if debounce key left is less than or equal to 0 and window.keyListener.isKeyPressed key event.vke. Then we'll do another thing. And what do we do if it's this way or that way? Well, we just rotate it 90 degrees. So if it's Q, we're going to rotate it to the left 90 degrees. So we'll say GameObject.transform. Actually, we'll have to say for, well, let's create a function for this one, because this one will be a little bit nicer to have function for. So we'll say rotate objects, and then we'll just give a degree. So float degrees. And then inside here, we'll say rotate objects. We'll do it 90 degrees if it's in here. And then if it is to the left, we'll rotate objects negative 90 degrees. And then inside of this function, it should be pretty simple. We'll just say for each game object in our selected objects, we will just say go.transform.rotation plus equals degrees. And that should be about it. So we're going to do this, but nothing's actually going to happen because we have no way to actually rotate these once. We have no way to visually rotate them. So we may be rotating them in here. In fact, what I'll do is I'll say system.out.println rotating. This is right. And if we run the game and we hit the E key after we select some objects, you'll see that it'll print that out, but we won't actually get anything. So I'll select this and I'll hit E, and you see it says rotating right. That also reminds me, don't forget to hit debounce key left equals debounce key. But you'll notice the object didn't rotate. It'll be a little bit more clear if I use a triangle, because triangles, you would definitely be able to see that rotation. So I hit E, it says it's rotating right, but the triangle does nothing. The triangle has been rotated, but we have no way in our render to actually render that change. So let's go into our sprite class, because this is where I did it in the last one, and it seems to be the simplest place to do a rotation. Okay, and so to rotate the object, we're literally going to do the exact same thing that's happening in the player bounds, except we're just going to move it over to here. So if we go into our player class right here, we can just copy all of this, so up to here, and then we'll go back into our sprite class, and we'll go down here, and we will just paste all of this into here, and instead of drawing the image, we will just draw the image at the transform with a null image observer, and this will officially rotate it. So we're doing exactly the same thing we did in the player's case. We just create a transform, we translate it, we rotate it about the center, and then we scale it, and then we draw it, which should do everything perfectly fine. So now if we place in a triangle and you hit E, first of all, you notice it's rotating the wrong way. We should actually do this math.toRadians and then rotate it. So we'll do this one more time and then run this. And if we place the triangle into there and we rotate it, there we go. You see we get 90-degree rotations. And if you press Q, you go to the left. If you hit E, you go to the right. You could make it differently if you think it should be differently. One thing we should also do is, you notice the green triangle selection box does not rotate with it. So if we rotate a triangle, let's go back to our level editor controls. We should also update the triangle's bounds. So we'll go down to triangle bounds, and then we will go to our calculate transform function, which is down here. We'll just make that public right there. And then we'll go back into level editor controls. Inside this selected objects loop, we'll go right down here, and then we'll say this should be go, not game object. And let's run that one more time, and this should work fine now that we have those simple bugs out of the way. There we go. So you see the triangle rotates and the green thing rotates with it. So that is almost all of it done. That's one other thing. We should recalculate the transform for the triangle too if it actually moves. So we can go down into our move function and just copy and paste this. And then we'll go down in this move function and we'll just paste it right here. Then let's go back in, make sure that's working correctly, and we can start working on box select if it is. So we move it, it works good, we rotate them, they work good. And you'll notice it rotates in place for each object, which is what I wanted. I didn't want it rotating around a certain point. You could add in like a mirror function that does do that. I would suggest looking into that and everything. It's a little bit more difficult to implement, but it would definitely be useful as well. So we have that function working. Let's create a box select function now. So first thing that we're going to need to do to enable box select is we'll have to add in a Boolean variable that will sort of trigger us to let us know that it was dragging the previous frame. We're going to initialize that to false. This will just sort of let us know if the player was dragging the mouse and then they let go, which lets us know, hey, they finished the box select action. Next, what we can do is we can go into our draw method, and if we just go down here, so we currently have it drawing the sprite that they're about to place. So we'll just wrap this into if is editing, and then we will do that. And then we'll say else, so if they're not editing, and let's actually make this an else if. We'll say else if window.mouselistener.mouse dragged. So if the mouse is being dragged, and window.mouselistener.mouse button equals, we'll actually move this down too because it's getting kind of long. But if it equals mouse event dot button 1, so they're left clicking, then we can say was dragged equals true. So clearly they are dragging this frame. Then we can say g2.setColor, and we'll say new color, and I did 111 0.3. So just like a semi-transparent white. And then let's import this class real quick. We'll import that right there. And then we'll say drag x equals, so we'll create a few floats up here too, just to let us know where the dragging is happening. So if we go up to here, we'll just have a private float drag x, drag y, and drag width, and drag height. And then going back down here, we will say drag x equals window.mouselistener.x, drag y equals window.mouselistener.y, drag width equals window.mouselistener.dx, and drag height equals window.mouselistener.dy. And the reason I have these is because we then have to do this. So drawing a rectangle, which is what we're going to be doing here to indicate where they're selecting with the box, you have to have all positive values. So we just have to make sure that if they're like dragging to the left like that, then we invert it and say, oh, they're starting here, and then draw it down that way. So That's what we're going to be doing right here real quick. So we'll just say if the drag width is less than 0, then we'll multiply drag width times -1, and we will move drag x to the beginning. So we'll just move the drag x and invert the width, because the width should never be -2. That's not a width then, right? Lengths and widths and stuff, those are all positive values all the time. So we'll do the same thing for drag height. So we'll multiply it by -1, and then we'll say drag y minus equals drag height. And then we'll just say g2.fillRect. Then we'll say int drag x, int drag y, int drag width, and int drag height. There we go, and that should be good. So we should see a box being drawn now if we start clicking and dragging, which is exactly what we get. And you'll notice that if we go backwards and forwards, it does not throw any errors if we go up and down, and that's because what we're doing is we're doing that inversion that I talked about in that last step, just to make sure that the x is always going from the appropriate place. But yeah, so we have the box being drawn, but now we want to actually test for like how many objects that they are collecting, and so that is, or selecting, and so that is a box cast sort of what we're going to be implementing. We'll implement it a little bit like that, but basically what we're going to say is right up here, right after we check and see if they clicked, we'll say else if not window.mouselistener.is pressed, mouse pressed, and was dragged. So we'll check and see if it is currently being dragged, and then right up here we'll add this little and window.getWindow.mouseListener.mouse dragged, and we'll say and not mouse dragged. So this way we don't trigger this if the mouse is already being dragged. So then if it's not being pressed and it is being dragged, we will check and see, or we will say, first of all, was dragged equals false. And then up here what we're going to say is and not was dragged. So this is just making sure that we weren't being dragged the previous frame. And then what this is going to check is it's going to check and say, okay, if the mouse was pressed and we were being dragged the previous frame, then we want to say that we are no longer being dragged and they finished the box select. And then what we want to do is deselect all, which is a function we will create in just a second. Actually, I think we do have that, don't we? We just have clear selected. Okay. So we'll say clear selected. So we'll say level editor scene equals level editor scene window.getScene. And then we'll say scene, or actually we'll say list of game object objs equals scene.boxcast. And then what we will pass it is our drag x, drag y, and drag width and drag height. So this also makes it a little bit easier for us in here. Drag y, drag width, and drag height. This will give us a specific box that we can use to do a box cast. And then what we'll do is we'll say for game object go in objs. We will add these to our selected object. So we'll say selected objects.add, and then go. Actually, do we have an add function? Add game object to select. No, okay. So we'll say selected objects.add go, and then we'll say if go, well, we'll say bounds b equals go.getComponent bounds.class. And if b does not equal null, then we will say b.selected equals true. So we'll just add all of them in real quick and do all that. We don't have boxcast implemented yet, so let's actually implement that real quick. And it should be a little bit easier than you might think. So the reason I did this in the scene is because I was referencing my old code. Let's actually take that out, and we will implement boxcast as just a function inside here. And we'll put it right below our raycast function, which is this add game object to selected. So then we'll go up here. We'll say public void boxcast. And then this will take in a float, x1, float, well, actually just float, x, float, y, and float width, and float height. And then what we can do is we will say float x0 equals x plus, and then we'll say window.getScene.camera.position.x. Copy that and paste it, and then we'll say y0 equals the y plus the camera's positions y. And then what we can say is list of game object objs equals new array list. So this is going to be the objects that have been included in this box, this select, and then we'll say for game object go and window.getScene.get all game objects. We'll loop through all the game objects and then test and see if they are inside this range. So we'll say bounds b equals go.getComponent bounds.class if b does not equal null, which technically should be all of them. They should all have at least one box bound. Then we'll say if we'll say game go.transform.position.x is less than, plus b.getWidth is less than, so if the right side of the box is less than x0 plus width, this guy's width, and if we have go.transform.position.y plus b.getHeight is less than y0 plus height, so and the y is less than the bottom, and go.transform.position.x is greater than this x0, and go.transform.position.y is greater than y0. So if all this is true, then we know that this object is contained within this rectangle. And let's actually make these less than or equal, just so that it's pretty sensitive and it picks up objects even if they're just a little bit close. And then we'll say objs.add geo. That way we have all that, and then what we'll do, this should not return void, this should return a list of game object, and then we will just return our objs down here. So now you can see we have no more errors down here. Let's test this and actually see if it works or not. So if we add in a few triangles and a few boxes, and we'll do something like that. And if we go here, you'll notice it selects them, and if we go here, it selects them. And you'll notice that you can do like that, so you can get halfway in and select only the ones you want. So this is box select. We now have box select implemented, and then you can just start moving them. While we're at it, let's do delete too real quick. Delete is really easy, and we should have that. So we'll just say if window.keyListener.isKey, well, we'll say if debounce key is less than 0. Let's go down here too, where we have all these other debounce keys. And we'll say else if debounce key left is less than or equal to 0, and window.keyListener.isKeyPressed. And we'll say key event.delete. VK delete, and then we'll just say for game, we want to delete these game objects. So what we want to do is we want to say for game object geo and selected objects. We want to remove them from the scene. So we'll say window.getWindow, actually window.getScene.remove game object. And then we'll give it the go that we want to remove. And then we will say, and then once we remove all the game objects, we'll say selected objects, or actually we'll just say clear selected. Well, we shouldn't do clear selected because we just deleted those objects. So what we should actually do is just say selected objects dot clear, and that should be good, because if we call our function, then it's going to try and access methods on those. What we could do, we'll just keep it like this, and then let's go into our scene and implement this remove object real quick, which should be not too bad. So it's a little bit weird though, because we do have to do a couple of things. So if we go into here and we say public void remove game object, we have to do a couple things. We have to prepare it. So let's create another list up here, a list of game objects. And this is going to be objs to remove. Reason we're doing this, and then let's initialize it in here, goes new array list, is because this function is going to be called inside our level editor controls, will be called in the middle of an update loop. And so if we just start removing objects in the middle of an update loop and then it goes to update that object, we're going to have problems. It's just going to mess things up. And so what we have to do is we have to wait till the end of the frame until we actually remove those objects. So we'll just put them in this temporary list. And if they say remove this game object, and we'll say game object geo, then we'll just say, okay, well, objs to remove.add game object. Then once the frame completes, so right inside init and then get all game objects, we have our update method and our draw method. Let's go into our level editor scene, and then we will go down to the bottom of our update loop. So you see we're looping through all the game objects here, and then at the bottom of our update loop right down here, we can say for game object geo and objs to remove, and then we'll just say geo game objects .remove geo. And then we should be good. Yeah, and then we should be good, because what this is going to do is it's not going to modify the list we're iterating through, which is objs to remove. It's just going to modify the game objects list. And then after we do that, we can say objs to remove .clear. Just clear up that list. And then let's add in one more thing. We'll just say if objs to remove .size is greater than 0. And we will add that in. Now let's try this real quick and see if it all works right. So if we add in a few objects, and then we decide we want to delete these ones, we hit the delete key. Well, nothing happens. So, well, they're gone. They're not doing anything. I think we just haven't removed them from the render. So let's remove them from our game objects, and then also render.gameObjects.remove geo. I think they were still being rendered. So we had just a memory reference and delete. So they're still not there because I can't deselect them or anything. And that's because our game objects is a list from an integer to game objects. So let's actually go back into our level editor scene. We'll say render, we'll go down here. We'll go render.get.gameObjects.get go.zindex, because that's where it is, .remove go. That should do the trick. And then let's try this one more time, see if it works. And what was happening there that you guys saw a second ago is a reference was hanging around. There we go. A reference was hanging around to those game objects, so they never really did get deselected. They just stayed, or they never got removed completely from the program. So Java didn't actually delete the objects, which means they were still in memory, just in the render, nowhere else. So this makes sure we remove them completely. They get cleared from memory, and then we can safely delete them. So that covers everything. We have box select. We have rotations. Now you can actually make a full level. Next thing we'll be adding is portals, and that should be the last thing that we have to add. So I'll see you guys in the next tutorial when we add some portals, and then I'll give you some notes about fixing things like this and tell you how you can fix that yourself. And then I'll do another tutorial on that stuff if you guys really want me to. But I hope you guys like this. If you did, please hit like and subscribe, and I'll see you guys next time.